Okay. I was. Okay, so last time we had just started talking about classes a little bit. If I remember correctly, the last thing I was going to do is I was just about to start talking about the word object. So basically, when we use the term object, we are referring to a special kind of variable. So in one sense, when you hear me use the word object, if that kind of gives you a panic attack or something, if you just think, oh, he's just using a big fancy word for variable, that will probably work just fine until you get a little more used to it. Hold on a minute here. I'm gonna turn off the chime. Okay, so in C++, an object is a variable whose type is a class. So in C++, we have the string class. And so when we have a string variable, we call it an object. We wouldn't normally call an int variable an object, for example. This is not 100% true. You may get into conversations with people where they would call any variable an object, but in general, I would say it's a pretty safe bet that usually we mean it's a special kind of variable. And so the difference in terms of using an object compared to using some other kind of variable is that if we have a variable that is an object, we can do things like put a dot after it and call a member function on it, right? So in one sense, you could say that's what an object is, at least in C++. If I declare an int, it won't make sense for me to say I dot anything. It just doesn't work because I is just a primitive variable. It's not an object, okay? So as you can see, in one sense, we have been using objects since the first week of class when we talked about strings. Just to sneak a little more terminology in here that we're going to have to use today. When I call a function using an object in front of the dot like this, the object is called the calling object. Okay, so you're going to hear that term a lot. The calling object, that's just the object that's in front of the dot. And the reason we say that is we say that stir1 is calling the substir function. And then we have this thing here, which we normally call the dot operator. I think more technically, it might be called the selection operator because it is selecting something that is contained in the calling object. So we're saying, give me the substir function that is inside a stir1. Okay. Another term you're going to have to know is client program. Anytime we have a program that uses a class, such as the string class, we call that program a client of the string class. Okay. Up until this point, we haven't really used that terminology. Normally, when we use it, it's when we need to distinguish between the class itself and the program that is using the class. So what we're going to be doing today is we're going to be talking about how to write our own classes. just like somebody else somewhere wrote the string class. Now we're going to be writing our own, and we're going to be sort of writing the class and the client program in parallel, because we have to have a client program in order to be able to tell if our class is working. So when we have that situation, we say, okay, over here on the one hand, I have the class, and over here on the other hand, I have the client program, which is the program that is using the class. Okay, any questions so far? I'm trying to get through the terminology and abstract stuff as fast as we can, so we can dive into some code here pretty quick. Again, bottom line, just to review, what we're trying to do here is we are going to create a new type. And so just to say, one thing that sometimes gets students confused is they think, okay, well, we're writing all this code, but what does it do? And so this is sort of a new situation, because we are writing code that doesn't do anything by itself. We're writing code that is creating a new class so that some other program can then use this code to do something. So the class itself is not going to have a main function. It's not going to actually do anything. We would need to have a main function if we wanted to actually test the code that we're writing in the class. Okay. So here we go with declaring a class. When we declare a class, we start by listing all of the components that that objects of that class will have. So let's go back and consider our date example again. And I guess I'm just going to go ahead and show you the syntax for this now. Well, no, I'm not going to show the syntax yet. I'm first going to make a list. Okay, here are the things we're going to have in our date class. We're going to have a day and a month and a year, because those are the three things we're going to need in order to store a date. And then we're also going to have some functions that operate on dates. So to start with, I'm going to have a function that I can use to print a date. I'm going to have a function that I can use to read a date. And I'm going to have a function that I can use to set a date. Okay, and then we'll add some more functionality to the class later as we go, but that's what I'm going to start with. I'm going to start with a class whose objects are going to have 6 members, 6 components. The technical term we use is members. Any questions so far? Okay, so what I want to do next is actually just give you a client program that would use this class, because I think that will make it clear what we are trying to accomplish when we get around to actually writing the class. So here's my client program. Okay, I'm going to declare 2 variables of type date, 2 objects of type date. I'm going to set one of them to this date. And I'm just going to use the print function to print it out. Okay, so this really isn't doing much. I'm just writing some code so that I can, once I have the class written, I can test it to see if it's doing what it's supposed to be doing. Now I want to read a date. So I'm going to prompt, and then I'm going to say date2.read. And then the date you just entered was date2.print. Okay. Let's call this temp. Temp. All right, so spend a minute staring at that. This should make sense. What I could have done, just imagine that I said, okay, I'm telling you that there is a class in C++ called date. Here's how it works. You can set a date like this. You can print a date like this. You can read a date like this. And so you should be able to look at this code and say, oh, okay, based on what Dave just told me, this program should work. Now I'm going to say, oh, I tricked you. C++ doesn't actually have a class like that. We're going to be writing a class like that, but it's the same idea. Any questions about what we're doing here? Okay, so now what I want to do is I want to get around to the task of actually declaring the class. Here's the way that a class gets declared. It's going to look very similar to how we did a struct. Okay, that's pretty much it. And at this point anyway, the syntax is exactly the same as it would have been for a struct, right? Okay, the only other thing you need, not the only other thing, but the next thing you need to know about how to declare a class is that the way we list those components, and I'm going to just start calling them members, that's the real term for it. The way that we list those members is by declaring them. So whether it's a variable like these, or whether it's a function like these, the way we list them is we declare them. So let me go ahead and do that. I'm going to have void print. That's a function declaration, right? If you're not clear on that, you might want to go back and read lesson 6 again. Excuse me. Yeah, that's a prototype. A prototype is just a function declaration. Here's my read function declaration. Here's my set function declaration. Okay, and then I've got 3 members of the class that are variables. So here's my declarations of those. All right. Any questions so far? Okay, functions that are members of a class are called member functions. Variables that are members of a class are called data members. Don't ask me why we reverse the terminology there, but this is what we call them. Okay. Notice that the print and read functions have no parameters. That might look a little strange to you. How can you have a print function with no parameters? What's it going to print, right? Well, it turns out you're going to see that quite a lot when you're defining classes, because it turns out that the member functions can access the calling object. So what my print function is doing is it's going to be printing the calling object. So for example, right here, when I say date1.print, what my print function is printing is not anything about the parameters, it's the calling object, which you will see in a minute, we can access from inside the print function. Let me just say that again. We can access this variable that was in front of the dot from inside the function that it's calling. Okay. Let's see. All right, one more thing we need to fix about our class declaration before we move on, and that is, and it turns out that this is very possibly the most important concept in CS 215. Don't worry too much if it's not 100% clear the first time you hear it, because we'll be circling around this over and over again over the next few weeks. But it's really important that we keep our classes independent and self-contained, right? What that means is, for example, I don't want my client program to know anything about these three variables, because those variables have to do with the implementation of the class. They don't have anything to do with what the client program needs to know about the class. So, you know, if I decide 10 years from now, I decide, you know what, I'm going to scrap this. And instead of having three int variables, I'm going to just make it a single string called entire date string. And I'm going to rewrite all of my member functions so that instead of operating with three integer variables, they're going to operate on this one string variable. I want to be able to do that and not break any of my client program code. All of my client program code is still going to work because I haven't messed with this. Okay, so these member functions here are what we call the interface. That's the part of the code that the class has to agree with the client program on. The client program needs to know about these functions, not how they're implemented, but how to call them. And the class has to know how the client program is going to call them. The class can change how it actually implements those functions as long as they still do what the client program is expecting them to do. Go ahead. Someone had their hand up. Go ahead.
Yeah, just a clarification on the terminology. When you say client program, what are you referring to there?
So the client program is the program that is using the date class. So in our specific example, this is the client program right here.
Okay, thank you.
So you can think of it as, you know, if you go get your hair cut, you are a client of that person cutting your hair, right? That's the same idea with the terminology we're using here. The date class is offering a service. And so if you're a program and you are using that service, then you are a client of that class. So anyway, I realized you probably didn't need to know that analogy, but since it came up, I thought I would put it out there in case that helps anybody. Any other questions before I go on? By the way, feel free to jump in with questions. The more questions, the better. This is like this is a pretty major jump we're doing here. So we're going to take our time and make sure that everyone gets it. Okay, so my whole point of that whole conversation about changing the implementation. I'm not really going to do that, so let me go back. My whole point is that I want to prevent the client program from being able to use these variables because I don't know, they may change. Or the client program may, you know, accidentally change them in a way that that introduces a bug into my class. So in C++, we put the word private in front of the members that we want to be inaccessible from outside the class. All those variables now are only accessible from inside the class. Okay, these other guys up here, the function prototypes, those we want the client program to be able to call those functions. So we're going to make those public. Okay. Any questions about that? All right, I'm gonna digress here a little bit, and I'm gonna draw a picture. This is a little bit of an experiment, so we'll see how this goes. But I wanna kind of dwell on that idea of separating the implementation from the specification a little bit more. So I'm going to create something here. That I'm going to call I want to get out of this. So I'm calling this area here between those two vertical bars wall of what did I have? Abstraction. Okay. In other words, this wall is the wall that we are using to enforce what we are calling abstraction. Don't worry too much about that word. I know it may be confusing at this point. I'm just throwing it out there for now. We'll talk a lot more about it. But basically, the idea is that over here, we have the client program. Over here, we have the class implementation. Okay. And then in the middle here, we have the wall of abstraction, which means the client program cannot see what's going on in the class implementation. The class implementation cannot see what's going on in the client program. Okay. But there's this wall of abstraction, and what's in here is what we call the, I don't know why I haven't just changed this whole thing to, what we have in the middle here is what we call the interface. And hopefully if the word interface makes sense to you, hopefully that'll make sense, because what goes there, though, that's how the client program interacts with the class implementation, right? So really what's there is the prototypes of those classes. The client program has to know how, the prototypes of those functions. The client program has to know how to call the functions, and the class implementation has to know how to set up the functions with the correct prototype so that the client program can call them. That's the only part that both of these entities, the client program and the class implementation, have to agree on. This interface is also sometimes called the specification, right? Because that's where we specify what are the member functions and what do they do when you call them. Okay, so this will not all make sense right now. I'm just putting it out there now so that as we continue talking, hopefully you can think back to it and it'll start to make a little sense. If we take a snapshot of this in your brain, because what I want to do now is I want to go back to our code and talk about which code corresponds to which part of this picture. We've got, if I go back to the code, why won't it let me go back to the code? Oh, I see. So here's the client program, right? That's the client program that was on the left side of my picture. These guys here, there will be more to the class implementation, but for now, the only part of the class implementation we have in our code is those three variables right there, right? Those cannot be seen by the client. And then the interface or specification is those three lines there. Those three lines specify how the client program and the class implementation interact. Okay. Any questions about that analogy? If you can formulate a question, that would be awesome. If you cannot, because it's still too fuzzy to even formulate a question, that's okay. Bear with me. Hopefully it'll become clear as we go. All right, so back to our more concrete stuff here. We want to get some code that actually does something, and we can compile it and run it, right? So all that is missing is the definitions of those three member functions: print, read, and set. So we're going to go ahead and do that now. For the most part, 95% of what we're going to do now is just what we've done a million times. We're just defining functions, right? There'll just be a couple of new things that we'll need to talk about. But let me just start by getting the print function up here. Okay. Here's what I think I need to tell you about this that's new. It may look strange. Okay, good question. Don't these functions have to be inside the class? The answer is no, and we're going to talk about that. That's like the next thing on my list to talk about. So great question, and we'll get to it in just a second. The first thing I want to talk about is just that this should look a little odd, right? Because I've got the word month here. That's a variable, but it's not declared inside this function. So what's going on with that? All right. For better or for worse, I need to talk about something a little bit abstract again in order to make this make sense. So far in our class, we have seen two different scopes, right? We may not have used that word. I'm pretty sure that it comes up in the textbook. But if you haven't heard it, that's okay. I'm defining it right now. Okay, a scope is just the context in which a particular variable has meaning or can be accessed. Okay, or not necessarily a variable, any identifier, a variable, a constant, a function, whatever. So for example, all of the variables that we have used so far in this class have been local variables. We've declared them inside a function, and they've been available to be accessed only inside that function. So that's local scope. However, we have declared constants globally, right? Meaning they can be accessed from anywhere in the file. Same with our function prototypes. Whenever we use a prototype for a function, that's declaring the function, and we're doing it at the top of the file, which means it can be used anywhere in the file. We don't worry about which function it is we're calling it from. We call it from anywhere in the file. So those are global functions. So that's the second scope that we've been using. Everything we've had so far has been either local scope or global scope. This variable here, now we are introducing a third kind of scope. Called class scope. Okay, and so the deal here is that this variable is not a local variable. It's not a global variable. It is a class variable. It belongs to the date class. So we say that it is in the scope of the date class. So that's why we can use it here, even though it's not declared local. Now, the next question is, how do we know that this is in the scope of the date class? And this is partly in answer to the question that was asked just a minute ago. Somebody asked, doesn't this function definition have to be inside the class? Okay, the answer is no, because what we do in C++ is instead of defining the function inside the class, we use this syntax. Okay, this double colon here, that is called the scope resolution operator. In other words, it's the operator we use to tell the compiler what scope an identifier is in. Okay, and what this means in this context is, okay, we are defining a function here named print, but we're not defining just a regular old global function the way we've been doing since about week 3 of the course. This is not a global function. This is a special function that is in the scope of the date class. Okay, in other words, another way of saying that is putting date : in front of the word print makes it so that it behaves the same as if the print function was defined inside the date class. All right, I have a couple of different directions I need to go with explaining some more stuff, but I want to stop and just see if anyone wants to ask a question about anything so far. Okay, so one direction I need to go with this is I just want to explain why we don't just define print inside the date class. Syntactically in C++, you can do that. The philosophy in C++ is, as much as possible, we want to make the declaration of the date class contain the interface, okay, the part that the client program needs to see. As much as possible, we want to keep everything that the client programmer doesn't need to see separate from the class declaration. Okay, so that's why we are putting the definitions of the member functions outside the class. So when I talk about the class implementation in my picture over here, I'm referring, I said before that I'm referring to these 3 lines here, but I'm also referring to any definitions of class member functions. Those are part of the class implementation. We want to keep them separate from the client programmer as much as we can. Now, if you're following this, you're probably thinking to yourself, well, sure, but how come these are part of the implementation, but we don't take them out of the date class? The answer to that question is, unfortunately, there's just no way syntactically to do that in C++. So they stay inside the class declaration. Time out just a second. Okay. All right, I know there's a ton of stuff just being thrown at you right now, so I'm happy to answer any questions. I'm happy to back up and go over something again if you have something you want me to go over again. Okay, so let me just get to something that's even more concrete than the stuff I've been talking about. And actually, let me just say that there's a lot of sort of abstract explaining why we do things certain ways here going on. So maybe what I need to do is back up for a second and just tell you what you really need to know. And what you really need to know is simply that when I define my member functions, I'm going to do it outside the class, and I'm going to put date : in front of the name of the function. That's all that stuff I've been talking about for the last 20 minutes. Really, in order to get your stuff to work, that's all you need to know. Eventually, you're going to want to know all the stuff I've been talking about, right? But if you're just desperately trying to figure out something to hold on to so that you can write some code, that'll work for now. Okay, the one other thing that's really practical in terms of being able to write your code that works is to understand what we mean when we use the word month right there, okay? When I use the word month there, it's not a local variable, right? It's this funny thing I've been talking about, the class, the part of the class scope variable, right? It's a class, it's a data member of the date class. So the deal is that when I use a data member inside a member function, what I mean is, and this will come out a lot smoother if I just use the specific example of month. So let me say it that way. When I say month right there, what I mean is the month data member of the calling object. Okay, so when I say date1.print right here, and I'm inside my print function and I say cout day, that means the day data member of date 1. And then the month data member of date 1. And then the year data member of date 1. Okay. And then later on in my client, I'm going to call date2.print. When I call date2.print, this is going to mean the day data member of date 2, and then the month data member of date 2, and then the year data member of date 2. Any questions about that? Okay. Let me go ahead and define my other two member functions, and then we'll have something we can test, right? So oops. You know, I just realized this is backwards, right? When I print a date, I don't print the day first and then the month, at least not in the United States, we don't. Yeah, okay. CM month. So this function, what I'm doing here is I'm writing a function so that if the user types in a date in the format month/day/year, I will read that date and store it in a date object. So I'm going to ignore the slash and then read the day. And then I'm going to ignore another slash and then CN the year. Okay, any questions about what's going on there? Okay, so a really good practice when you're writing computer programs is always stop and think if there is something that you can test before you move on, right? Because it's better to be able to test your code and make sure that it all works before you just keep moving on, and pretty soon you've got 1,000 lines of code and none of it works, right? incremental development. So I think that the only thing I don't have defined now is my set function, right? So what if I comment this part out and I just do the read and the print? I think I should actually be able to do that right now, right? We'll actually run this thing and see if we have some code that works. Enter a date. So I will enter 11/6/2016. The date you entered was 11/6/2016. So apparently everything we have here is working now. I'm going to pause. Stare at that for a minute. Let me know if there's something you want to look at more closely. Okay. Quiet bunch today. Let's do the last thing that's left to do, which is define our set function. Okay, so for set, I'm just going to say month. It's in month. Day gets in day. Year gets in. Anybody want to ask a question about what's going on there? All right, so let me run this.
Excuse me, I do have a question.
Sure.
Can you scroll up a little bit, please? Yes, in read, like you already assigned like something to month, day, and year, right?
You're referring to this part?
Yes.
Okay.
So there is already something in it.
Well, that depends, right? Right here, when I read, it depends on what the calling object was, right? So first of all, in the client program, the read function came after the set function, but that's really besides the point. When I call set, I'm putting data into date 1, right? When I'm calling read, I'm putting the information into date 2. Okay,
Okay.
All right. I could flip that around if I wanted to. I could use the same variable twice instead of using two different variables if I wanted to, and then it would just replace the values that were in there before.
Okay.
Okay.
Thank you.
All right. So we're going to just test this, make sure it's working. Date 1 should be 4/27/1947, and it is. Now enter a date. So I'll make up a date. 1/19/2021. That you just entered was 1/19/2021. So obviously we're not writing a program that does anything very exciting, right? But it appears to be working correctly. Anyone not sure what just happened or what the program's supposed to be doing or anything like that? Okay, so basically what I'm going to do now is I have a couple more functions that I want to add to my class just to sort of give it a little more functionality But also just so that we have a chance to kind of play around with writing classes a little bit more. You'll see some examples of situations that come up that that may be helpful when it comes time to write your own classes. And then, well, we won't have time even to get through that today, but next week, I just have a couple other details about classes that I need to tell you about, and then we'll be done with our first week on classes. So again, in case you're not following along with the schedule, we're actually talking today about the topic that is on the schedule for next Monday and Wednesday. So we're doing fine. We're not behind. We're a little ahead, but that's good because there's some stuff coming up that's a little more time consuming. So I'm trying to get a little ahead. Okay, here's what I want to do next. I want to be able to compare two dates to see which one comes first. Okay, so I'm going to write a function named comes before. It's going to return true if the calling object comes before the argument. Okay, so what should I write here in my else part? Someone want to suggest what should go there?
Date 1 does not come before date 2.
Good. Any questions or comments about what we're trying to do here? Okay. So let me go ahead and get my prototype for this going. That's going to be a value returning function that returns a bool. The name of the function is comes before. What's the type of the parameter?
Type date.
That's right. The parameter is a date. And you can tell that, just to be clear, if you're not sure what to put here, but you have the client program in front of you, the client program tells you what the type of the parameter is, right? You just go here and I say, okay, the argument was this variable. What type of variable is that? That's a date variable or a date object. So I don't even have to think about this. I know that what goes here is a date. I'm going to just call it other date. Any questions about that? Okay, so one of the reasons that I chose this function is because I just wanted you to see an example where one of the parameters was a date object, because you'll have something similar to that when you're doing your assignment. Okay, let's define that function now. Okay, so now let me just say what this function is supposed to do. I want to just state it very precisely so that there's no confusion. Returns true if the calling object comes before the parameter other date. false otherwise. Everyone clear on what we're trying to do here?
Yes.
Okay. All right, so here's my suggestion. There are other, different ways to do this, but I think the clearest, simplest thing is just to start with the year. And I'm going to say if year of calling object is less than year of other date. Obviously, that's pseudocode, and I want to talk about how to translate that into C++, but I want to get the concept down there first. Then return true. Everyone understand why that pseudocode works? Hopefully that's clear. If the year of the calling object is 2019 and the year of the other date is 2020, then nothing else matters. I just know the calling object comes before the other date and I can return true. Any questions about that? Okay, someone tell me what to type in order to replace that with actual C++ code. How do I say the year of the calling object?
We should put here.
Yep. Right, just talk down here in print. Remember I was talking about when I said month, that means the month data member of the calling object. I'm doing the same thing here. I mean the year data member of the calling object. Okay, and then how would I say the year of other date? Right. That makes sense to everyone? Okay, I will take that as a yes. So now what I want to do is I'm just going to do the opposite, right? I also know that if the year of the other date comes before the year of the calling object, then I can instantly return false. So if other date dot year, actually, let me just stick with the year on the left. If the year is greater than other date dot year, return false. Everyone okay so far? Questions, comments? Okay, you guys are easy. So what do I know at this point in my function? If I've gotten to this far in my function and I have not returned anything yet, what do I know is true?
The year is equal to the other year.
Right, the years are equal, exactly. So what I'm going to do now, since I know the years are equal, I'm going to check the months, right? I'm just going to say if month is less than other date dot month. Oops, return true. Because I know that the years are equal, right? So I can just base my decision on the difference of the month. Ooh. Okay. Now I know that the years are the same. If I've gotten to this point in my function, I know that the years are the same and the months are the same. So at this point, I'm just going to return true if I'm going to return day less than other date dot day. Right. Any questions? Okay. Let's add something else. What does the return statement do exactly? In general, the return statement evaluates whatever the expression is that you've given it, and then it returns that to wherever the function was called from, right? So down here in main, we called the comes before function. So let's say if the year of date 1 is less than the year of date 2, then what's going to happen is that's going to trigger this return statement. And so the comes before function is going to return true. And then that true is going to get substituted right here. So this condition is going to turn out to be true. Is that what you were asking?
No, I guess my question was, could you go up to the function? How could you return day is less than other date dot day if it's a Boolean function?
Well, so if I evaluate that expression, the result is a bool value, right? It's either true or
Okay,
false.
so that's just basically true or false.
The expression that I have highlighted there is either true or false, right? I'm using the less than, so it's gonna either evaluate to true or it's gonna evaluate to false.
Okay, thank you.
That makes sense? Okay. All right, anybody else? And is that good with everyone? You know, I could say if day is less than other date dot day, return true, else return false, but that would just be a longer way of saying the same thing. Okay. So I'm done with the comes before function. Let's move on to the next member function that I want to add. Probably not going to be able to finish this next one, but I want to use the time and at least get started on it. So the next thing I'm going to do is I want to add a function to the class named increment. So 1 day later, date 2 is okay. So I want to make sure everyone understands what the point here is. What this increment function is supposed to do is it's supposed to take, oh, you know what I didn't do? I didn't actually test our code to see if it works or not. Unless there are any requests to the contrary, I think what I'm going to do is just go ahead and assume you're okay with that and that you will trust me when I say that it would do what we expected it to do with the comes before function. And we'll see that in a minute, or actually, I guess we'll see that on Monday when we test our increment function. But so the increment function should change its calling object so that it is equal to 1 day later than the current value of its calling object. So if I enter December 9th, 2007 for date 2, this is going to change it to December 8th, 2007. I got my dates right. And then it's going to print that new value. Everyone clear on that? Just advance it 1 day. Let me just point out that I could have made this a value returning function that returned a date that was 1 day later than date 2. I pretty much arbitrarily decided that I'm not going to do that. I'm not writing a value returning function here. I'm writing a function that actually is going to modify the calling object and advance it by 1 day. Okay. So let's go ahead and start writing this. I'm going to have a function. It's a void function. And increment, no parameters. So that's the prototype. Then I'm going to define that function, void, big colon, colon, increment. And what's that function going to look like? So when even if it's not exactly 100% correct, tell me what's the basic idea. Okay, that's the basic idea. I just want to take this opportunity to make sure everyone understands, and sorry, Erica, I don't mean to pick on you, but I want to make sure everyone understands that that's not correct syntax, right? If you said date gets date plus 1, that would be correct syntax. Right, or date plus plus would also be correct syntax, yeah. I just wanted to point that out because it's such a common, that's such a common mistake that I see students making, and it actually means something completely different. So just make sure you have that right. So either one of these would be fine. In C++, usually we just go with that since it's slightly less typing, I guess. Okay, so, and actually not date. There is no such thing as date, right? What do we mean there?
It's only day, right?
Yeah, just day. I didn't even realize that at first until I was about to go on. Yeah, so that should be day plus plus. That is absolutely correct. That will do the right thing 97% of the time, right? What's the problem? When will that not work?
When it's at the end of the month.
Right, when day is the last day of the month, that's not going to work, right? If the day is January 31st, that's going to make it January 32nd. That's not going to work. So here's how we're going to work that. We're going to just fix that. We're going to increment day or the last day of the year, right? But that's subsumed, right? It's the last day of the year. It's also the last day of the month. But that's a good point. We'll get to that. So I'm going to say so we just incremented the day. If day is too big, so if day is greater than something, you can help me think about what goes there. Then what do I need to do? If day is too big, what do I want to do?
I want to increment the month.
Increment the month, right? Anything else?
And set day to 1.
Set day back to 1, right? Everyone clear on that? We haven't figured out the question marks yet, but aside from the question marks, everyone okay with that so far? And then we have to do something similar for the year, but let's hold on to that for a second. Before we talk about the year, I want to talk about this question marks. It turns out that figuring out what goes there is complicated, right? If the month is January, then I want a 31 there. If the month is June, then I want a 30 there. If the month is February, then it gets even more complicated. I don't know if it should be a 28 or a 29. So hopefully just listening to me talk like that, my hope would be that you are all thinking the same thing, which is we need to just write a function to do that. Okay? I'm not going to ask how many of you were thinking that. I'm just going to hope that that's what you were thinking. And I'm not saying that to make you feel bad if you weren't, right? I'm saying that in the hopes that it may encourage you to have that mindset in the future. So anyway, I'm going to just put a function call there. I'm going to say num days in the month. Oops. Okay. Any questions about the syntax going on there? Well, let me just say a couple words. This is the first time that we have seen what I'm doing here is I'm calling the num days in month function, and the calling object is going to be the same calling object that I'm already currently working on, right? So when I called increment the first time, the calling object was date 2, right? Date 2.increment. So date 2 is the calling object. So inside here, date 2 is the calling object. So if I say num days in month without a calling object in front of it, it automatically means the num days in month function of that same calling object, which was date 2. Okay. So I don't need any arguments here because I just want to know what the number of days in the month of the calling object is. So I need to go write that, but we're going to just assume for now that it exists, and I'm going to finish this function. And then after I have finished this function, I'm going to have to go write the num days in month function. All right. So as a couple people have pointed out, we're still not completely done here, right? Now we're what, 99.7% of the time this is working. The only time it doesn't work now is if the day was December 31st. So I'm just going to have another if statement here to fix that. If month, right? So if saying month plus plus made month equal to 13, whoops. And this 12 should actually probably be a named constant, but I'm not going to go there just yet. So if month is greater, if incrementing month caused it to go beyond December 31st, what do I need to say here? Year plus plus, month is January. Right. Okay. All right, so I hope that went okay. That was a pretty big day for us in terms of getting introduced to classes. This may be one of those lectures you just want to go back and watch 3 or 4 times just to make sure you got everything. We will wrap up this example on Monday. And if there are no further questions, I will see you then.
Thank you.